Hi friends, I am Shravana and welcome back to my channel Sparkling Future. Before starting with today's topic, I request all of you to subscribe to my channel and also please like, share, comment and hit the bell icon for the latest video notifications. Thank you. Friends, in today's video, we will see how to implement the get method for the doubly linked list. So this get operation is typically to fetch the value that is present in the given position or index. So now let's see one sample doubly linked list. So here we have 5 elements. Now let's say you wanted to get the element that is present in third position 0, 1, 2, 3, third position. Then we use the get method. So usually during the when you are working in the runtime environment like production environment, if you wanted to get, there will be a lot of in the doubly linked list kind of a structure and you wanted to fetch one particular detail from out of that node, then this get method will be used. So how to get it? So now it is kind of, we have to start from the head method for performing. For example, if we wanted to get what is present in this position, right, what in this index, what is the data that is present in this node, for getting that we have to start from head and then we have to traverse to each and every node and check whether that index is matching or not. This is how it works in doubly linked list. Okay, so now how can we do that is, we have to have create one, like the head, we have to create a temporary variable called current, and for every current dot next means for every node we have to traverse through it and then we have to see in that given index what is the value, then we will return that. That is how it works. Now let's write the code for this. So I have this method which we have used in the yesterday's like a previous lecture. Now I am going to Google, searching for Python online compiler. I am randomly selecting the first result. So I am pasting it here. So this is the doubly linked list that we have. When I run it, it has 5 elements. Okay. Now let's add the code to get the element from the index that we want. So definition get node or something, I'll just create a function for that, and then we have to pass the index because we wanted to know in that particular index what is the data that is present in the node, right? Now again, when we are always talking about the corner cases, right, so first we have to think about the index that we are entering it here, right, that's a user input. So we have to take care of that index should be less should not be, I mean should be greater than 0, right, should not be less than 0, and that index should be less than or equal to length of the node, right? Now let's add one condition here and see if you can add this. Okay, you can consider this as an assignment and you can give in the comment section how do you add that if condition for testing the index is less than or equal to the total length of the doubly linked list. Okay, now for checking that if index is less than 0, okay, then we will return none because it is wrong. Less than 0 will not be a possible index in the doubly linked list. Okay, now as I mentioned, let's have a temporary variable called current and we will assign the head pointer to that current, and let's take a variable called count here. Then we will increment because here we have to traverse through each and every node here, right? So for that we have to have the count in hand so that we can uh, use that as a counter. Now we are starting with count 1, right? So while count, so next time for every time if, until that is not 0, are not like as per the length, right? Are none mainly. It's not none, while current is not none. What we have to do, if again we have to check if the index is the first element itself, that is also possible, right? So we will check that condition. If the count is equal to index, next immediately we will return it, right? Because in the 0th index itself we have the current value. I mean the current index is matching with the index that user is passing, then we will return the current data. Okay, otherwise what we will do, we will increment count to 1, and then again we will current equal to current dot next. We will traverse through that until when, until count is none. So till that place means at the end where it reaches the tail, that's where it will become the the current position will be none. Here not the count, okay, here the current, because current is where we have the self dot head and we are traversing through each and every node of the doubly linked list. Okay, and then finally we will say if anything is out of bound, right, then we will say return none. This will take care of this condition as well. Okay, now let's test this and see how it is behaving. dll dot get node of, let's print the third value. Print I am giving. So what we have asked is third index. So it starts with 0, 1, 2, 3. So in the third index we have element 4. So that is what it has given. So now let's say what is there in the second index. What is there? 0, 1, 2. It should return the value 3. It is returning the value 3. So this is how we can get the value when working on the, I mean using the get node or get using the get method in the doubly linked list. Now let's discuss on the time complexity and space complexity of this particular method. Now here we are traversing, we are starting with the head and we are traversing through the tail node, right? And if you take the best case, for example, here now it starts with 0 and then 1 and then 2 and then 3 and then 4. Here we have until 4th index elements in this doubly linked list. Let's say user is inputting as I wanted to get the element which is at 0th index, which means that the first in the head itself, because this is the 0th index, right, he will be able to get the value immediately, right? So this is the best case. And the worst case scenario is, let's say the user has given 4. Number 4 means every time it has to check for each node and each index and see if that current node index is or user input index is matching with this current node index. So that is the worst case. Here the traversal or the looping means multiple times the same operation we have to repeat, like go to next, check for the index, compare the index, and then again go to next, compare the index. So this repetitive or traversal operation is present. So the time complexity of this operation is order of n. Okay, so for get node, what is the time complexity? Order of n. Now coming to the space complexity, what are we doing here? We are creating a pointer called current and then we are just comparing it with the index and we are returning. We are not adding anything or we are not making some memory related or some space is needed kind of operations. We are not doing it here. So the space complexity of this particular method is order of 1 because it's a context. One time we will see, it's kind of a constant, they say it as what is it, it's a constant variable, right? Like we don't have anything to create any additional data structure or additional storage. So the space complexity of this operation is order of 1. Okay, time complexity is order of n and space complexity is order of 1. Okay, this is all about the get method in doubly linked list. Thank you for watching the video, friends. Please subscribe to my channel for more interesting learnings. Thank you.